Ooh, this is a peach of a video. You're going to like this one. We're talking social media algorithms. We're not just talking, we're building. But first off, why is social media so addictive? We hear about the algorithm. The algorithm is controlling me. I was on TikTok there, and 2 hours later, I looked up and it was nighttime. Where did the day go? Or it was on YouTube, and I just kept getting video after video after video of this really obscure niche. Don't know why, but I couldn't take my eyes off of it. I was glued. And it's the same on Facebook, Instagram, and all of that stuff. We hear about this thing called this algorithm, this ethereal creature controlling ourselves. But what is it? It's a recommender system. Recommender system is like a class of applied mathematical problems. And they're all over the place. Amazon has them. You log into Amazon.com, you're going to get a bunch of content tailored towards you so that you buy more goods. And there's a really sophisticated recommender system around that. Netflix, they had a $1 million bounty on their recommender system to try and get people to watch more content and to stay more glued to their platform. That was like over 10 years ago at this point. The amount of R&D that have gone into these algorithms over time, it's sick. Online shopping, music, content, and social media. And the social media version of these recommender systems, it can be a little bit scary. We're going to talk about it, and we're going to design our own. So how do they work? Well, Mark Zuckerberg, Elon Musk, anyone who owns a social media website has all of their data that they want to send to the users. And a user, you can't consume all of the data that's online. There's too much data. Even if you were scrolling this quick, you still wouldn't be able to process it all. So they have to filter out what they send you. And in this case, what they filter out is the stuff that will bore you. And they only show you the types of social media content that could go as viral as possible. And what will go viral? Stuff that will go viral is stuff that keeps you on their app longer, keeps you coming back to their app more frequently, and causes you to click around and interact with their system more often. So they take all of the actions and all of the content, and they look at how people are interacting with that, how frequently they're coming back, how frequently or how long they're staying watching for. They plot all of those points, they represent them, and they look for, hey, we've identified this little cluster here. If we keep feeding this content to a user, then that user is going to be more addicted. They'll increase their time they're on their app. They'll increase the frequency they come back, and they'll increase the amount of clicks that they give our platform. Step one, represent the data spatially, and then identify the little clusters that are super addictive. Typically in social media, the stuff that we find that's most addictive, it's your cute cat videos, that type of content. It's your funny content, the push notifications, the bane of my existence. And also the type of content that keeps people polarized. Have you thought to yourself in the last week, the last month, oh, I hate this class of person. Maybe it's like a different person with a different political opinion to you, or whatever it is. Or maybe it's just a competing sports team or something like that. Conflict spikes anger. Anger drives dopamine. And all of this type of content, it triggers a dopamine response in you. Dopamine makes us feel good. And when we feel good, it's almost like a little bit of a high. But the problem with the high is you get that spike of dopamine, you feel good, and then you come down again. And you're like, I'm drained, I'm bored, I've got nothing to do. And then you just out of boredom, you pick out your phone, you start interacting again with stuff, and you're like, oh, and you get that little bit of a hit each time you use these sites until the point of which you're basically addicted. So these social media sites are almost like little drug dealers. They're dealing you little hits of dopamine for free. All it's costing you is your time. But what's time, Loads of that. I think the next iteration of the internet, people will have a lot more say in what goes on in the algorithm. I think there will be almost a civic responsibility to be involved in what's going on in your algorithm. But in this video, I'm going to describe a very, very simple recommender system and very simple algorithm, should I say. And over time, I'll add complexity with future videos. But just for now, we're going to talk about a very, very simple recommendation system. Our success metric, as with any project, if you're not measuring against something to succeed, you're at nothing. So we're going to measure the like to dislike ratio over time. So I'm going to design an algorithm that gets fed to a user, and the user can either like what they see or dislike what they see. Or in this case, also they can skip, but we can talk about that. They'll like what they can see, they dislike what they can see, and we want them to like more stuff than they dislike, of course, and then we want that ratio to keep going up and up. So we want our algorithm to get better and better and better the more the user interacts with it. The data for this project is coming from Nostr. Nostr is the best place to get data for social media stuff at the moment. Right now, Twitter have paywalled all of their data. When I was first building recommender systems, when I was first learning about social media data, I was playing around with Twitter data that I could scrape online for free. Now it costs $100 a month to do that. So I'm not using Twitter anymore. Facebook closed off. They walled up their gardens long ago. You used to be able to like get your neighbors, get all of your social graph and get the social graph of your friends and all of that stuff and do some really cool stuff with Facebook data. Instagram, similarly, it's closed off, very similar to Facebook. TikTok, forget about it. Reddit, they're closing off their systems now too. But Nostr is a free and open protocol. It's an absolute goldmine for data scientists. I'd encourage you to try playing around with it. I've built my own API. It's there available on the GitHub if you want to go to it and play around. You can deploy your own API to this Nostr protocol, fetch your own data, and Bob's your uncle. So we're going to use Nostr data for this recommender system. And remember, the goal of these systems is we need to figure out what cluster or whereabouts what are the tweets or what are the messages or what are the pieces of content that we can send to the user. And typically these pieces of content are clustered together when we can represent our content in some spatial orientation. And to do that, to represent the content spatially, we're going to use what's called an embedding model. What the hell does that do? Well, an embedding model, it takes text, it takes text as input, and it spits out spatial coordinates as output. And the idea behind these embedding models is if I have two pieces of text that are kind of similar, they will live in close places to each other in this spatial representation of these texts. Maybe to make that a little bit more tangible, you could imagine Manchester United content would be spatially similar to Manchester City content because they're both about the city of Manchester, about the sport of soccer, and they're rivals. So they're probably talking back and forth between each other a lot, mostly in English too. So spatial representations of those two football clubs is probably quite similar to each other. And Barcelona then might have some similarity. It might be close to those, two clubs, but not as close as Arsenal, for example, because Arsenal is also another English Premier League team. But then if you wanted to talk about machine learning, any content around machine learning lives nowhere near the content about Manchester United, Manchester City, Barcelona. Well, that is until this video, but before this video. Anyway, in essence, these embedding models, they position pieces of text that are similar close together and pieces of text that are very different from each other far away. So that's how we will represent our data as points. I'm using planets here to represent the points. And imagine I'm a Manchester City fan. I'm not. I have no opinions over Manchester City. Imagine I was a Manchester City fan and all of the Manchester City content lived in this little cluster here. If I'm completely obsessed with Manchester City, I only want to see content that lives there. But the problem is, next day, a Manchester United fan might log into this site, and that Manchester United content might live somewhere different. and the machine learning content might live somewhere different. And before a user starts interacting with my site, I don't know if they're a Manchester City fan, a machine learning fan, if they like, science or whatever they're interested in. I don't know. So I have to start learning what they like. And we're going to use we're going to use little planets to represent the content points. And we're going to use a little spaceship to represent the user. And the user's job, the user wants to only receive content that's in that little white circle. And our first iteration with this model is we're going to guess some random position in space. We're going to draw a circle around that random position in space. And we're going to select pieces of content at random that live within that circle. And we're going to show those to the user. And that's how we're going to start learning about what the user likes. And that's kind of the basics around how this algorithm works. And so if a user likes a piece of content, well, let's go into the details. Let's say we've picked this random position in space. Our user is a Manchester City fan. Manchester City lives inside the white circle. We've selected at random this blue circle planet. We go to the Manchester City fan. Yo, what you think? Do you like this piece of content? Now, you and me watching this video, we know that if they only like stuff within the white and this within the blue, they're not going to like this. So they say, I don't like it. And so what our algorithm does is that initial position that we guessed for them, let's move it a little bit further away from the planet that they just inspected, that piece of content that they just saw. So that planet has like an anti-gravity field against this little space cadet. Now let's pick another planet at random. Again, we don't know, we do this at complete random. Again, we go ask the astronaut, what do you think? Do you like this piece of content? He likes it. And since if he likes the content, he gets moved a little bit closer to that planet. So back and forth over time, it's that same process. If they dislike stuff, we push them away. If they like stuff, we push them close to it. And that's the gist around this algorithm. Over time, they're going to get selected more content at random, and it's going to jiggle them around until hopefully, if they've used it enough, they end up in a position where they're only getting Manchester City content. That's it. That's how the algorithm works. And that's it. Like that's the most technical details that we'll talk about, really. It's not that technical. If I was to translate that talk into code, step 1, fetch data from Nostr. Step 2, map data to the embeddings. And we're using OpenAI's embeddings. Step 3, send the data to the database. Step 4, create an initial guess for what type of content that person might like. And step 5, ask them, hey, did you like that content? If so, we're going to move you closer to it. If not, we're going to move you further away from it. And that's it. There's like less than 50 lines of code. Again, that code is going to be completely available. It's going to be linked in a GitHub repo to this video. And I'm also going to make it available on Replit eventually, so that you'll be able to play with it on Replit too, and not just on your own GitHub local machine. What does that recommender system look like in action? Well, what I've got here is this is real Nostr data. I just clicked on that link there to plot up what this person looks like, verifying my something identity. Okay. And let's start putting ourselves in the mind of a user of this algorithm. The algorithm is working in the background. I can either dislike, like, or skip content. Let me just click skip a few times just to show you what it looks like. So it's picking out different pieces of content that's close to the user initially. And you can see a lot of the times there's this media object, Nostr object coming up in the content that gets selected. What's going on there? Well, with the recommendation system that I've designed, it doesn't factor in images. It's not able to describe what's in an image. It's not able to describe what's in a hyperlink. It's not able to describe if there's like a retweet, what's going on, the piece of text that it's retweeting. So these are like limitations. So I've got like a placeholder tag there for now. That's this like square brackets Nostr object, square brackets media object. That's what's going on there. And I guess since I'm the designer of this algorithm, and this is like a limitation of it currently, in a future video, we're going to integrate other forms of media and we'll build up this algorithm over time. But for now, it's not able to handle it. So I'm going to click dislike and hide all of my my errors in my code. Anytime I see a Nostr object or media object, I'm going to click dislike. And I'm going to slowly tell the algorithm, hey, anytime you see anything with a media object, Nostr object tag, move further away. And anytime you don't see that, let's move closer. Again, so let's move closer to these ones. Dislike. This is another type of Nostr note. Okay, like that. We like that. We like that. We like that. We dislike that. And so you give it a bit of feedback over time. We've given it, we started training it at 10. We're now at 25. So we've given it 15 impressions. And you'll see already it doesn't really recommend anything with tags anymore for us, right? So it's pretty good. Okay, I saw there's one or two in that region that still have tags. So let's give it a few more dislikes for those, few likes for the stuff that doesn't. And okay, this is one. Boom, boom. Beautiful. Okay, perfect. This is like looking much better now. So we've learned to not we're not really getting anything with media tags, but I noticed that we're sometimes getting content that's not in English. Let's train that out of the system. So I only want to see English content and I don't want to see any media tags. So as a user, I'm changing the goalposts. I'm making myself more picky, and I'm hoping that the algorithm again learns not to give me any of that type of content that's not in English. Okay, still giving me stuff that's not in English. Media object. Boom, boom, boom. I'm seeing a lot of content about zaps, some media objects. I don't really see anything that's not in English anymore. Let me click skip a few times. This will kind of give me a sample of what's in the region around. Okay, I think we filtered out all of the non-English stuff. That's good. But I don't care about zaps. And it keeps feeding me information about zaps. So let's try and filter out the zaps out of the system. So anytime I see the word zap, I'm going to dislike it. Zapathon seems to be trending a lot. Okay, that's definitely getting filtered out. Definitely filtered out. Zaps. Okay. Again, we're trying to move away from zap space, if you'll get me. And everything used to be kind of coming around about zaps. There's some non-English content again. Let's get that away. Some media content. But as you can see, first off, we filtered out media tags. Now we don't really see many of those. Now we're filtering out zaps. We filtered out non-English stuff. And over time, it should be getting better and better. And it kind of is. Again, I'm just continuing to do some ratings. And of course, different ways you could make this algorithm better. Include stuff from your social graph. Include those media objects, and there's ways that you can get image data into these recommender systems. It's not that difficult. It's super easy to do. You just need to take the time to do it. A more sophisticated search algorithm, increase the amount of randomness. Like Amazon, for example, with their news feed, they're gonna show you what they think you'll buy, but they'll also show you like random stuff that they don't know if you'll necessarily buy or not, but it's so far away from stuff that you've seen before that they just want to test it out on you because potentially you could buy it in the future. But let's see. So the real test of how well this is doing is if we look at the plot down here, blue is likes, orange is dislikes, and green is skips. Now I clicked a bunch of skips just to show you what's going on. But what you want to compare is you want to compare blue against orange. And as you can see over time, like initially I was seeing more content that I disliked than I liked. But then it started improving. First of all, we got rid of the media objects. And then I got more picky and I'm like, hey, I also don't want to see anything related to a different language. And so then it started learning that and it got better and better. And I'm like, okay, but now I don't want to see anything related to zaps. And now it's getting better and better again. And just like over time, the more we interact with it, the better it's getting, which is like super successful. We're using very, very simple logic. We've built a recommender system that can detect what type of information you like, what type of information you don't like, and learn from you. The more you interact with it, the more you use it. That's quite a powerful thing. 50 lines of code. Again, I'm going to have more tutorials coming along on this recommender system. We're going to be able to search for content, and that can like speed up how quickly we learn. And we're going to make more sophisticated, so we'll have different ways. We won't just be looking at one circle and looking at events around one circle. We can introduce multiple circles. Eventually, might make this into an app where we're looking at screen time, we're looking at likes, dislikes. We'll include all of that content. So stay tuned if you're interested in building your own recommender system. And of course, all of the code is going to be up there online. So you should really try and play around with this yourself. If you do build something, share it with me. I'd love to see it.